You know, there's a specific sound in a restoration shop that just makes every master metal worker cringe.
Oh, yeah.
It isn't an engine backfiring or, a wrench hitting the concrete. It's that high-pitched scream of a grinding wheel fighting against a sheet metal door panel.
Hmm. It is a heartbreaking sound. I know exactly the one you mean.
Because the pros know, usually before they even look over, that that panel is being ruined.
It's the sound of hours, maybe even days, of fabrication work just being undone in seconds because someone got impatient or grabbed the wrong tool.
Exactly. The metal is getting hot, it's getting thin, and someone is about to have a very, very bad day.
It's the sound of heat warping a panel that was, perfectly straight just 5 minutes ago.
And that is exactly what we're digging into today. Welcome back to the show, everyone. We are here to save your sheet metal and, honestly, probably your sanity.
It's a big topic.
It is. Before we get into the sparks and the noise, I need to make sure you know that this deep dive is presented by Bluewater Auto Restoration.
That's right. And this is week 3 of the 2026 Bluewater Auto Restoration podcast.
We are fully into the swing of the new year.
We are. And judging by the questions we're getting, a lot of you are deep into some serious metalwork right now.
We sure are. And just a reminder for anyone new joining us, we release new podcasts every Saturday morning, so you can listen while you're brewing that first cup of shop coffee.
Perfect timing.
Today we're tackling a topic that seems basic on the surface, but is actually full of hidden complexity. We're calling it the cutting wheel smackdown.
I like it. It's a bit of a battle royale.
It really is.
We aren't just talking about spinning discs in the abstract. We are looking at a three-way fight for supremacy right there in your toolbox.
The contenders are the tools everyone owns, but, and this is the key, most people misuse, we have the carbide, the grinding wheel, and the flap disc.
And I think for a lot of people, they see those as interchangeable.
Right, you just grab whatever's on the grinder, right?
And then that is the fatal flaw.
Yes.
That's how you destroy a project.
So what's the core idea here?
The premise we need to start with is that this isn't about which tool is better in a vacuum. You can't just throw away your grinding wheels and only use flap discs.
So not that simple.
Not at all. It's about understanding that each of these tools has a distinct personality, a distinct physics, and a very specific mission.
So the goal today is to give you, the listener, the knowledge to look at a repair and know instinctively which tool prevents the nightmare of a warped quarter panel.
And which one is the sledgehammer you grab when you just need to, obliterate something?
Exactly. We want to move you from guessing to strategizing.
That's the key. Strategy over brute force.
Let's unpack this by meeting the contenders. I want to start with the one that, I'll be honest, scares me the most. Contender A. I call it the surgeon, the carbide burr.
The surgeon is a perfect analogy. It really is. When we talk about a carbide burr, specifically tungsten carbide, we're usually talking about a bit that goes into a die grinder.
And those things spin incredibly fast.
Oh, incredibly high RPMs. Maybe 25,000 RPM. But the key difference, the thing that separates it from the other two, is how it removes material.
Because it doesn't feel like grinding. It feels sharper, more aggressive.
It is sharper. It doesn't grind at all. It mills.
Mills. Okay, break that down for us.
Think about the difference between rubbing a piece of wood with sandpaper and hitting it with a chisel.
Okay.
The sandpaper relies on friction and abrasion. The chisel relies on a cutting edge. A carbide burr is essentially a tiny high-speed milling machine in your hand.
So it has actual teeth?
It has flutes, actual cutting teeth, that slice chips of metal off the surface.
That explains so much. That's why when you use one, you get those nasty little slivers that stick in your clothes and your skin.
Exactly.
Versus the fine dust you get from a grinding wheel.
Precisely. You're creating chips, not dust. And because of that, it has an incredibly aggressive bite. It's rigid. It offers extremely high control because it doesn't flex, but it also has zero forgiveness.
Zero forgiveness. Meaning if I slip with a piece of sandpaper, I scuff the paint. If I slip with a carbide burr...
You've dug a trench.
Yeah.
It goes exactly where you put it, for better or for worse. Its footprint is tiny, which makes the pressure immense right at that point.
So its best use case is what?
It's for localized shaping.
Yeah.
For getting into tight corners. You are not going to use this to smooth out a hood.
No.
You'd be there for a year, and it would look like the surface of the moon.
Okay, so that's the surgeon. Highly specialized, dangerous if mishandled. Let's bring in Contender B, the grinding wheel. This is the one I think of as the sledgehammer.
The Type 27 depressed center wheel. This is the classic. It is a solid, bonded, abrasive. It feels like a stone because, for all intents and purposes, it is a rock.
It's heavy, it's loud, and it just eats metal. But how does it actually work compared to the carbide?
It works through brute force abrasion. It's millions of tiny, sharp grains bonded together in a matrix. To get it to cut, you generally need pressure and speed.
So you have to lean into it a little.
You do. It's designed for heavy stock removal. If you have a massive weld on a structural I-beam or you're building a bridge, this is your tool. It's an industrial beast.
But in our world, in the context of auto restoration, say on a 1960s Mustang quarter panel, is it the hero or the villain?
It's often the villain. It really is. It removes welds incredibly fast, but it is the high-risk, high-reward, or high-risk, high-disaster option.
Because it gouges so easy.
It gouges. If you tilt your angle just 5 degrees too steep, the edge of that rock digs in, and you fin the metal significantly. You've created a low spot you now have to fix.
And we really can't talk about grinding wheels without talking about the danger factor. I mean, these things are under immense stress.
It is a spinning rock held together by glue and mesh. OSHA takes this very, very seriously. You absolutely must use proper guards on abrasive wheel machinery.
Why is that so critical?
Because if a grinding wheel catches an edge and shatters, it doesn't just break. It explodes. It becomes shrapnel moving at bullet speeds. I am not exaggerating. You cannot respect this tool enough.
So we have the surgeon and the sledgehammer. Now for Contender C, the flap disc. I like to call this one the body man's daily driver.
But that's a great name for it.
It just seems like the friendliest of the bunch.
It is the most forgiving, certainly. Physically, it's a fascinating design. Instead of a solid rock, you have these radial layers of abrasive cloth flaps.
Like a deck of cards fanned out in a circle.
Exactly. Imagine that. And that layering does something to the feel of it when you use it.
It does. When I use a grinding wheel, I feel every single vibration. It chatters across the metal. But the flap disc feels so much smoother.
That's the magic factor right there. The flaps act like a suspension system for your grinder.
A suspension system, I like that.
As you press down, the flaps compress and flex. This cushion absorbs the chatter. It allows the abrasive to conform to the curve of the metal rather than fighting it.
So if I'm working on a curved door skin, the grinding wheel wants to cut a flat spot.
But the flap disc wants to wrap around it. It flows with the panel.
Which means its primary role is what?
Blending, shaping, and feathering. It grinds and finishes simultaneously. Now, is it as fast as the sledgehammer at removing a giant chunk of steel?
Yeah.
No, but that flexibility means you aren't gouging the metal. You are trading raw destruction speed for control and for surface quality.
So we've met the team, but we need to establish the arena, the rules of the game. Because we aren't building skyscrapers here. We're doing restoration. And that changes the rules completely, doesn't it?
It changes everything. It's a critical distinction to make. If we connect this to the bigger picture, industrial fabrication is often about structural integrity and speed on thick steel.
Right.
Restoration is about preservation. You are working with finite, often irreplaceable material.
You can't just go buy another fender for a rare 1930s coupe. That steel is all you have.
Right. So we have 4 priorities that define the rules of the Smackdown. These are the things that matter most in our world.
Yeah.
And priority number 1 is heat control.
This is the big one. This is the ultimate enemy. Why is heat so destructive?
Metal moves when it gets hot. We all know that. But in a constrained panel, like the middle of a door, when you heat one spot, it tries to expand.
Makes sense.
But it's surrounded by cold metal that won't let it expand outward. So where does it go? It expands upward or downward. It warps.
And then what happens when it cools?
It shrinks. And it often shrinks past its original shape, pulling the surrounding metal with it. You get what's called oil canning.
That's where the panel pops in and out, right? Like an old oil can.
Exactly. It's a nightmare to fix, a complete nightmare. So controlling heat is everything.
Okay, that's number 1. Priority number 2, panel thickness.
You have to preserve the original steel. Every single spark you see flying off that grinder is a piece of the car leaving forever.
You can't put it back.
You can't put it back. And if you thin the metal too much, it becomes weak, flimsy, and prone to cracking down the road. It loses its structural integrity.
Got it. Priority number 3, surface quality.
Paint reveals everything. It's the ultimate truth teller. You might think a panel looks smooth in the raw steel, but once you put a glossy clear coat on it, every scratch, every divot, every gouge looks like the Grand Canyon.
So the underlying metalwork has to be pristine.
It has to be as close to perfect as possible.
And finally, number 4, Clean transition zones.
This is all about blending. When you weld in a patch panel, you don't want to feel a ridge. You don't want to see a line. You want it to be seamless, as if it was one piece of metal from the factory.
So if we're judging by those 4 rules, the winner of this Smackdown isn't the tool that eats the most metal the fastest.
Not at all. The best disc is the one that gives you a controlled result with the least amount of collateral damage to the surrounding panel.
All right, I think the stage is set. Let's get to the main event, the Smackdown. We are going to put these 3 tools head-to-head in 4 specific real-world categories. Category 1, fastest metal removal.
Okay.
Who takes the belt?
The grinding disc. It's not even a fair fight. No contest.
And why does it win so decisively on speed?
Pure physics. It is built for aggression. It's a rigid, hard bond. You can put your body weight into it, though you shouldn't, and it will just chew through metal.
So if you have to remove a lot of stock, like a poorly welded bracket or something.
Like bubbling thick plate for a frame repair, the grinding disc is the predator. It is designed for bulk removal, period.
But there's a massive catch, isn't there?
A huge catch. It wins on speed, but it loses badly on safety for the panel. It generates immense friction heat.
There's that enemy again.
There it is. And it has that high risk of digging in on the edges we talked about. So, yes, it's fast, but it's like using a chainsaw to carve a turkey. It works, but the result is a mess.
Okay, verdict. Used for bulk removal on heavy steel, never for finishing on sheet metal. Category 2, weld blending. Now we're talking about the delicate stuff, quarter panels, roof skins, door skins. Who wins here?
The flap disc. And specifically, I'd say one made with a ceramic or zirconia abrasive.
Okay, why the flap disc? Why is it the champion of blending?
It goes back to that suspension system we talked about. A car body is rarely perfectly flat. It has crowns and curves.
Always.
A grinding wheel is flat. If you put a flat rock on a curved door, you are going to create flat spots. The flap disc bends. It flexes. It follows the contour.
And that means it produces a better finish.
A much better finish. It produces a predictable, fan-shaped scratch pattern that is much, much easier to cover with primer later on. The gouge resistance is the key.
You want to shave the weld, not the door.
That's the perfect way to put it.
Yeah.
The flap disc allows you to do that with precision.
All right. Category 3, cleanest, precise work. We're talking about tight spots, awkward angles.
This is the surgeon's territory. The Carbide burr wins this one, hands down.
Paint a picture for us. Where is the Carbide absolutely unbeatable?
Okay, imagine you're working inside a door jamb or a tight corner where the dashboard meets the A-pillar.
Yeah, a 4.5-inch grinder is not fitting in there.
It simply, physically cannot fit. The Carbide burr is the size of your pinky finger. It can get into those inside corners. It's perfect for cleaning up what I call weld boogers.
Weld boogers. I love that term. We all had to deal with them.
Those little splashes of weld metal inside a seam that you can't get to otherwise, the Carbide just zips them right off.
What about for things like spot welds?
It's the only tool for carefully opening up a spot weld if you've drilled it, but the panels are still stuck. You can go in and surgically cut the remaining nugget without destroying the bottom layer of metal. It's an amazing tool for that.
But the limitation is area, right?
Absolutely. It is not for broad smoothing. It's a point source tool. Think of it as a Dremel on steroids.
Category 4, and this is the big one for restoration,
What?
the one that keeps people up at night. Lowest chance of warping sheet metal.
The winner is the flap disc, but we need to really explain why, because this is where a lot of the confusion comes from.
Let's get into the physics of heat generation. Why does the grinding wheel lose so badly here?
So friction creates heat. A grinding wheel, by its nature, requires high pressure to cut. It has a solid contact patch with no real airflow. All of that energy from the friction is dumped directly into the steel as heat.
And it happens fast.
Instantly. It stays in one spot, and within seconds you see the metal turn blue. If you see blue metal, you've changed the metallurgy, you've stressed it. You're on the verge of warping it if you haven't already.
Okay, and why is the flap disc different?
2 reasons. First, the flaps themselves allow air to circulate between the layers as it spins. It's like it has its own cooling fan built in. It just runs cooler naturally.
That makes sense.
And second, because it distributes the pressure over a slightly wider, softer footprint, you aren't generating that intense pinpoint heat spike. It spreads the load.
But you added a caveat when we were planning this. You can still warp a panel with a flap disc.
Oh, absolutely. It is not magic. If you lean on a flap disc and hold it in one spot on a big flat hood panel, you will warp the panel. Physics still applies.
So it's not foolproof.
It's not foolproof, but the risk profile is much, much lower. It gives you a larger margin for error. It's more forgiving of small mistakes.
Okay, so we've pitted them against each other, but the reality of a working shop, a productive shop, is that they aren't enemies. They have to be a team.
Exactly. The Smackdown is great for highlighting their individual strengths, but in practice, you use them in a sequence. It's a strategic alliance.
This brings us to Section 4, the BWAR.CA workflow. This is the sequence Bluewater Auto Restoration recommends for getting the best results. So let's walk through a hypothetical repair. Say we're patching a rust spot on a fender.
Okay, visualize the fender. You've cut out the rusty section, you've fabricated a new patch, it's held in place, ready to weld.
So step 1 is the cut.
Before you even weld, yeah. We use a cutoff wheel here, an honorary mention in our Smackdown. The rule is make straight cuts, never freehand jagged curved lines.
Why straight cuts?
Straight lines disperse heat more evenly during welding, and they're way easier to weld without distortion. A jagged line concentrates stress and heat in weird ways.
Okay, good tip. So now, step 2 is the weld.
You MIG weld it. But please, do not run a continuous bead on a fender. If you do that, you've warped it before you even pick up a grinder.
So what's the technique?
Use tacks, a small tack weld here, then move 6 inches away, another tack. Move to the other side of the patch, another tack. Stitch it together, letting it cool between each little weld.
Okay, now we have the patch welded in. We have a row of what look like dimes sticking up the weld bead. It looks like a mountain range on the fender. So we move to step 3, the knockdown.
This is where you grab the grinding disc, the sledgehammer.
But I thought we said not to use that on sheet metal.
You do, but you have to be incredibly disciplined. You are using it only on the weld crown itself. Do not let it touch the parent metal.
You're just decapitating the mountain.
Exactly. You are knocking the top, say, 80% of the weld off. 1, maybe 2 quick, light passes. Your only goal is to lower the height of the weld quickly without putting too much heat into the panel. Then you put it down.
Got it. The mountain is now a small hill. Step 4, the blend.
Now you switch to the flap disc, probably a 40 or 60 grit. This is where the artistry happens. Your goal now is to feather the edges of that little hill.
You're blending it down.
You're blending that hill down until it is perfectly flush with the fender. You can't feel the transition with your hand.
And because you use the grinding disc for the heavy lifting, the flap disc doesn't have to work as hard, right? Which means less heat.
Exactly. You save the life of your extensive flap disc, and more importantly, you keep the heat way, way down. You aren't asking the flap disc to eat half an inch of steel, it's just doing the final shaping.
And then finally, step 5, surface prep.
Now the metalwork is done. You're ready for the first coat of epoxy primer or a skim of filler. So you switch to a finer flap disc, like an 80 grit, or better yet, a dual action sander with maybe 80 grit paper.
And the goal there.
You want to erase the deep scratches from the 40 or 60 grit grinding phase and leave a uniform tooth, the consistent scratch pattern, for the primer to grab onto.
It's such a logical progression. Brute force first, but only where it's needed. Then shaping. Then refining. It stops you from asking one tool to do a job it was never designed for.
It creates a workflow where you are always moving toward a finer finish, rather than chasing your tail trying to fix the gouges and the warp you created 5 minutes ago.
Okay, this is so useful, but speaking of the tools themselves, let's go a layer deeper. Section 5 is about selection guide and material science, because I walk into the supply store and I see a wall of flap discs. Different colors, different numbers. It's overwhelming.
It is, and choosing wrong costs you money and wasted discs, and more importantly, it can hurt the quality of your work. Let's talk grit first. The number on the disc matters immensely.
Walk us through the numbers. Let's start aggressive. 36 grit.
36 grit. This is basically driveway gravel glued to a plate. It is for very aggressive shaping. I'd use it maybe for shaping a leading edge as a patch, but I would be very careful with it. It leaves very deep scratches. Scratches that can actually show through the primer and even the paint if you aren't careful to sand them out completely in the next steps. So avoid it for general finishing work.
Okay, how about 40 grit?
That is the sweet spot for weld blending in our workflow. It cups fast enough to remove the weld efficiently, but it leaves a scratch pattern that is manageable to remove with 80 grit.
And 60 grit.
A great choice, a little more controlled blending. If you are nervous about thinning the metal, or you're working on a very delicate panel, start here. It's slower than 40, but it's safer.
80 grit.
Now we're in the prep stage. You aren't really removing stock anymore. You're scuffing the surface for adhesion. You're smoothing out the 40 or 60 grit scratches.
And something really fine, like 120.
Final refinement. Do not try to grind a weld down with 120 grit. You will just generate friction, you'll burn the abrasive off the disc, and you'll heat the panel. It's like trying to sand a floor with a napkin.
Yeah.
Wrong tool for the job.
Now, let's talk about the material itself. The color of the disc. I see blue zirconia. I see reddish-brown ceramic. What is the actual difference? Is it just marketing hype?
It is definitely not marketing. It's chemistry and physics. Zirconia is your standard industrial workhorse. Usually it's green or blue. It's good. It's been the standard for years.
But ceramic is the next level.
Ceramic is the game changer.
Why is it that much better? It's usually more expensive.
It is. It's all about how the abrasive grain breaks down as you use it. Old school aluminum oxide, and to some extent zirconia, dulls over time. As you use it, the sharp points of the grains get round.
And round grains don't cut.
Round grains rub. Rubbing creates friction and heat, not efficient cutting. Ceramic grains, on the other hand, are engineered to microfracture.
Wait, they break on purpose?
Yes, it's an engineered failure mode. When they experience pressure and heat from grinding, the crystalline structure fractures to reveal a new sharp edge underneath. It is constantly self-sharpening.
That is fascinating. So as it wears, it actually stays sharp until the grain is gone.
Exactly. And because it stays sharp, it cuts with less pressure from you.
Yeah.
Less pressure means less friction, which means less heat.
So it cuts cooler.
It cuts cooler, it lasts longer, and it cuts faster. It costs more up front. But for restoration where heat is the #1 enemy, ceramic is the only choice, in my opinion.
Let's circle back to the grinding discs quickly. Given their risks, when should I actually reach for one?
Frame repairs. Absolutely.
Right.
If you are boxing a frame, working on a heavy-duty bumper bracket, or beveling a 1/4-inch steel plate for welding, anything thick and structural,
And where should you absolutely avoid them?
stay away from the exterior skin of the car. Hoods, roofs, doors, quarter panels, just don't do it. There's almost always a better, safer option.
And for the carbide burrs, you see a million shapes. Which ones do I actually need to own?
You can get by with just 3, really. First, a tree or flame burr. Looks like a little pine tree. That's for contour shaping and getting into corners.
Okay.
Second, a cylinder burr, the one with a flat top. That's for flattening surfaces or deburring an edge. And third, a ball burr.
What's the ball burr for?
It's incredible for inside corners or for carefully hollowing out a spot weld without going through the panel underneath.
This is great stuff. I feel like I need to go reorganize my entire abrasive drawer. But before we finish, we have to talk about the don't do this list, the common mistakes that we see people making over and over.
These are the habits that ruin cars and waste money on tools.
Okay, mistake number 1, the grinding disc as a finisher.
We've harped on this, but it bears repeating. If you try to finish a fender with a grinding rock, you will leave deep gouges. You will create a wavy, uneven surface that requires a bucket of body filler to hide.
So you're creating hours of work for yourself.
Hours of work to save 2 minutes of changing a disc. It's a terrible trade-off.
Mistake number 2, the flap disc as a cutoff wheel.
I see this constantly in shops. Someone is too lazy to grab the cutoff tool, so they turn the grinder sideways and try to cut a bolt with the edge of a flap disc.
And why does that fail so spectacularly?
Because a flap disc is made of cloth flaps. It isn't a solid, reinforced wheel. It loads up with metal instantly, it overheats, it smokes, and it smears the metal rather than cutting it. You will ruin a $10 disc in about 10 seconds.
Just a complete waste. Mistake number 3, too much pressure.
The caveman approach. You think that pushing harder makes it cut faster?
It feels like it should, intuitively.
With modern ceramics, it's the exact opposite. Companies like 3M are very clear in their technical data. Their precision-shaped grain is designed to cut with light pressure. Let the abrasive do the work.
What happens if you lean on it?
You crush the grain before it has a chance to microfracture and self-sharpen. You turn the cutter into a friction heater. You're just rubbing the panel and making it hot.
Okay. Mistake number 4, sitting in one spot.
This is the cardinal sin of sheet metal grinding. If you keep the grinder spinning in one 2-inch area for more than, say, 5 seconds, you have likely warped that panel.
So you have to keep it moving.
You have to keep the tool moving. Keep it dancing across the surface. Think of it like ironing a delicate silk shirt. You don't just leave the hot iron sitting in one spot.
And mistake number 5, wrong disc angle.
Yes. A grinding wheel is usually used at a shallower angle, maybe 15 to 30 degrees to the surface. If you go too steep, the edge digs those trenches.
And a flap disc.
A flap disc also requires a specific angle to fan the flaps out and use the abrasive correctly. If you run it perfectly flat against the surface, you aren't engaging the abrasive properly. You need a slight tilt, maybe 5 to 15 degrees.
Now, before we wrap this up, we have to talk about safety. And I don't mean just wear safety glasses. I mean the physics of things exploding.
This is vital. We are dealing with RPMs that are honestly terrifying if you stop and think about them for a second.
First up, RPM matching.
This is the silent killer. You have a grinder that spins at 12,000 RPM. You go to the hardware store and buy a cheap, unrated disc, or one that's only rated for 8,000 RPM. Centrifugal force takes over. The outer edge of that disc is trying to pull away from the center harder than the resin and fiberglass holding it together can withstand. It can disintegrate. It explodes.
So you must always check the rating on the disc and compare it to the rating on your tool.
Always. Never exceed the max RPM of the disc.
Second, guards.
I know. They get in the way sometimes.
Yeah.
They can block your view. And a lot of people take them off.
Well, don't do it.
Don't. That OSHA requirement, 29 CFR 1910.215, isn't there to annoy you. If that stone wheel shatters at 10,000 RPM, the guard is the only thing standing between that shrapnel and your neck.
Which brings us to PPE, personal protective equipment.
Eye and face protection. This is non-negotiable, especially with the carbide burrs.
Why? Especially with those.
Remember, they don't make dust, they make chips. Tiny, hot, needle-sharp slivers of steel flying at you at high velocity. If that gets in your eye, it can embed itself and rust immediately. It is a serious medical emergency. Wear a full face shield.
Absolutely. We want you to finish the car, not finish your day in the ER. So we have covered a massive amount of ground here. We've broken down the contenders, the physics, the workflow, the mistakes.
It's a lot to absorb, but if you just start applying that basic workflow cut, weld, knock down, blend, finish, your metal work will transform, I promise you.
You'll use less filler.
You'll use less filler, you have straighter panels, and you will be so much less frustrated at the end of the day.
So what is the final verdict? If the listener takes one single sentence away from the Smackdown to write on their shop wall, what should it be?
One sentence. I would summarize it like this. Grinding discs remove the most metal. Flap discs make the best panels, and carbide fixes what the other two can't reach.
I love that. It simplifies the chaos of the toolbox into a clear strategy.
It's all about respect for the material. When you use the right tool for the right stage, you aren't fighting the metal, you're working with it. And the metal knows the difference.
That is very well said. Just a little housekeeping before we sign off for the day. Don't forget to visit the website at BlueWaterAutoRestoration.com.
There's a ton of great info there, project galleries, and resources to help you out with your own build.
And remember that our podcasts are available on Spotify, Google Music, YouTube, Apple Podcasts, Amazon Music, or SoundCloud.
So whether you're in the shop, in the truck, or stuck in the office dreaming about the shop, you can take us with you.
That wraps up week 3. Next time you pick up that grinder, just take 1 second to pause, look at the disc that's on it, ask yourself, am I about to be a surgeon, a sledgehammer, or a daily driver? Because choosing the right tool for the job right now saves you a massive headache later. Thanks for listening, and we'll catch you next Saturday.
Stay safe and keep building.